Um, so what we're actually working with today isn't necessarily going to be something that you're going to be doing a lot of. You're going to see a lot of these terms throughout the rest of the course, but the actual like specific processes that you go through, you're probably not going to do too much of, at least from writing out. Like maybe internally you'll do it. That's the point of it, is to get you internally to do it. You just do it without thinking. So you're not going to probably beyond this chapter see something where it's going to go, write the converse of this, write the inverse, test this sentence out, see if it's correct, so okay? So when we get into the next chapter, well, actually the end of this one and then the next chapter and the one beyond that, these are like the ones where you guys write out formal explanations the most. This is like the start of that. Formal explanation meaning like you're going to solve a problem and give a reason for each step and why you're solving it. And that means that you're going to have to really keep track of things like definitions, theorems, properties, postulates, all these things as we go through. It's going to be a long list of things. It's going to be a lot of stuff to try and organize, guys. And I try my best to tell you guys which things you definitely need to focus on so you're not bogged down with hundreds of definitions and theorems and stuff. Okay? All right, so to start with, all right? The point of today, again, is just to kind of get your mind thinking in a specific manner, and that's it. We're going to do rewriting of sentences. We're going to be looking at a specific type of reasoning. You guys just did kind of reasoning if you found some of the patterns on the warm-up problems. But the idea is to get you thinking in a logical manner, okay? And it's very straightforward kind of thinking. You probably already do some of it, whether you realize it or not, and you probably never put words on it, like names, titles to it. But that's the whole point of today, is to give you specific titles and terms to use for this type of thing. Okay, so the first term, not the title of it, not the inductive reasoning, but the first term you need is conjecture. Conjecture, guys, is just it's a statement based on what the heck you see. It could be anything, all right? It's basically you looking at something that's happening and saying, I see this happening, I'm going to make a conjecture saying that this will happen all the time. Okay, you do it all the time, you do it every day. You probably don't vocalize most of it. This is a lot of internal kind of thought process. But every single day you guys are walking around, you're observing stuff, and you're making statements on it. It's just human nature. It's where it goes. Yeah. Kind of like a hypothesis, yeah. Okay? And what we'll be working towards is basically proving these conjectures or proving the hypothesis. But we'll be doing it with geometric properties, theorems, definitions, postulates. We've already seen that word. Okay, so we'll be working through problems using geometry, but it'll basically be, I got to prove this conjecture, I got to back it up with something. The something you back it up with is your definitions and postulates and so on. Now, to practice this, what I got there. To practice it, we'll be doing things like the patterns that you just had up there. You'll be rewriting specific types of statements just to kind of get your mind thinking in a specific manner. But all of this really is just kind of building up to you writing out a formal explanation or formal proof. Okay? I mean, that's the main idea with this stuff. All right? So you can write everything down up there if you want, or you can summarize it, or, it's not big time if you write every little thing down. Okay, now with the conjecture thing, okay, because that's going to be one of the main focus points in the beginning. May I go past this? Can we stay? What? Wait? Yeah. Good. I will wait. Good? Close enough? Yeah? Objection? All right. Okay, so essentially the act of making a conjecture is you got to be able to find a pattern about something that's going on. And again, you do it every day, whether you do it subconsciously or not. It's something that you just do. Or else, you know, if you can't do this, you're probably not going to be able to function in everyday life anyway. But the act of making a conjecture is you find a pattern based on whatever we're dealing with. Like if you did the stuff in the warm-ups, it would have been, here's a group of numbers. You find the next 2 or 3 numbers, and then they would say something like, make a conjecture based on what's there. In this case, your conjecture would be, I added 10 to get the next number. I added the next square or the next odd number or whatever, that kind of thing. But if you were able to get at least some of the problems, you know, I understand the ones with the letters were outside of the box thinking, but if you got the ones at least with the numbers, you have that kind of thought process going on already, whether you realize that's what you're actually doing or not. So if we did, let's say the first one, and I got the next 2 numbers there. Where are the next 2 numbers? For just the top pattern. That's all I'm looking at right now. Yeah, but no, okay, just 5,
6, 7, 6, 7, 8.
Okay, I agree. And if I said, okay, tell me why, that would be me asking you essentially to make a conjecture based on why you got those. Why'd you pick those?
The patterns 1, 2, 3, 2, 2, 3, 4, 2, 3, 4.
Okay, but you got to give me some kind of sentence. Give me a reasoning. What do you think?
The last 2 numbers, the first 2.
I could probably go with that within the realm of what's there. What do you think?
You just add 1 to each number.
Add 1 to each number. I could go with that. That's fine.
Start it with the middle number of the last sequence.
Fine too. I understand all that. Okay. It's a matter of you have to find a way to explain like the little tiny things that are going on to say, okay, this will work every single time. Now, obviously, if I went beyond these, then I think a couple of you guys it would kind of start messing up pattern-wise what will come next. But based on what we see up there, those were fine. Okay. What if I now change that from the constricted numbers and gave you something like this, where they're giving you a set of statements saying, look, this happens, this happens, this happens. Okay, all these things are happening at the same time. Based on these 3 statements, make a conjecture. Like something, and again, a conjecture would be you're observing all this stuff happening. You make a statement that is kind of enveloping all this and saying this is always going to happen no matter what. What do you think? Sun come up tomorrow morning. Is that fine? Does it fit what's going on up there? Yeah? Anyone disagree? And we got a different one? You don't have to, I'm just saying. I'm just asking if anyone got a differing opinion, because if you do, that's okay. I'd agree with that. That's fine. Okay, just linking them all together, that's good. Okay? All right. Now, beyond that, the next step, okay? The next step would be, okay, you get a conjecture, you see something, you see an observation going on, you take this conjecture and you form what would be a conditional statement, okay? A conditional statement involves both a hypothesis and a conclusion. When we deal with them in here, they're usually written in a very specific form. And the form that it's written in is such that you can look at it and flat out tell what the hypothesis is and what the condition is. Just like a conjecture, these are kind of like true or false statements. Again, they're based on whatever a specific individual is seeing, which means that they don't necessarily have to be a true statement all the time. Some can be false. It happens all the time. Okay, people make conjectures and someone disproves it and you go, oh, man, that's how it goes. All right, same thing happens with conditional. All right, with the form that you guys will see it most in, it's called if-then form, meaning it'll be like, if such and such happens, then here's the result. And it's always going to be in that form, right? I shouldn't say always. It's usually going to be in that form for you guys. The reason it's set up that way is that you want to try and have something where you can pull a hypothesis and a conclusion out of a statement quickly. If it's in this form, such as like that, if it's in a form like that, then you can pretty much look at it and go, here's the hypothesis, here's the conclusion. All right. If you're writing all this stuff out, take note of the part that says the hypothesis comes after the if, and the conclusion comes after then. Because if it's a test, a state test, R test, whatever, and they give you a conditional and it says something like, here's your conditional, tell me what the hypothesis is. They do not want to see this section here included. Like that, the sidewalks are wet, that's the hypothesis. The sidewalks being wet, that is the hypothesis. When you do it and you identify like if with it, if you kind of repeat that, you have a tendency to get marked down a little bit. Okay? It's a little picky thing, but that's to be 100% correct, that's kind of what you got to do. What you'll see is when we write proofs, there's a lot of little picky things that come about. Okay? And then again, the conclusion would be this section. Okay? You don't include that word, the conclusion would be it's been rained. All right? Which again, that statement there could be tested as true or false. Someone could give that to you. Like that, the things you could do right now is I could give that to you. I could say, what's the hypothesis? What's the conclusion? And then I could say, do you think this is a true or false statement? Do you think it's true or false? What do you think? Is that a true statement? If you say it's true, that means that's basically the only way that thing could happen, the statement that's up there. Like there's nothing else that could possibly happen. Meaning, for that hypothesis, the only way you can get the conclusion is if that hypothesis happened. What? False? Okay, if you say it's false, you have to provide something called a counterexample. Counterexample just means something that will disprove the statement. Is there any other situation where, let's see, the conclusion is rain? Is there any other way where you can have sidewalks that are wet? Sprinklers. You have a car wash, something like that. You could have what? Kids what?
Oh, spilling his water.
Kids spilling his water. Look klutzy. Oh well. It's all right. Okay. So, and again, that little thing, right? Like when you see these, if it says, is it true or false, you got to test it for every single possible situation. Okay. Sorry to put that up there. All right. Now, what we'll do is I'm going to go through the different ways to rewrite these. Okay. There's four ways. Three ways. Three. Sorry. I'm including biconditionals. That's not rewriting. And what we'll probably do is I'll do this for, we'll make up a conditional. Okay. So for the conditional, we'll do, say like, if, give me a hypothesis. I don't care what it is. Wow. School appropriate hypothesis.
If it's hot out.
If, never mind, really? You do something that wasn't school appropriate? I was trying, you said it is hot out?
Yeah.
And just leave it as if it's hot? Shorter I make this, the better off it is. It's hot? Is that good?
Yeah.
Okay. Well, then you give me the conclusion. No, you gave me the hypothesis. Then what?
The sun is out.
Then it's daytime.
Oh, that was a better one. I was getting creative
That's a
here.
good one.
What?
Then the sun is
Yeah,
out.
it's all right.
Yeah, it's good.
The sun's up. Okay. All right. So that's our conditional statement. That means I could come up here and I can go, okay, my hypothesis is it is hot, right? Because I don't include if. And the conclusion is sun's out. Okay. All right. So that's like our starting point. Okay. Now, the whole act of rewriting these, again, is kind of just to do like a logical thought kind of process, all right, where you're going to take the original and switch things around, negate them, change words, so on. But they're in a very specifically like logical format so that you can then take your original statement and test whether these things are true or false every time, like without doubt. Mostly to prove true, because proving things are false is easy. You just find a counterexample. All right, so the first one's up there is converse. That's the one that you guys are going to see the most. Okay? A converse of a conditional statement is you take the original conditional statement and you reverse the positions of the original hypothesis and conclusion. All right? Therefore, you are creating a new if-then statement, but it's just going to look a little different. All right, so this is our original. All right, so if I did the converse of what we have over there, the converse would be if, what was the original conclusion? All right, so it would be if the sun is out, then, what was it? It's hot?
It's hot.
Okay. That'll be it. Again, there's nothing else technically we're doing with this right now besides just rewriting it, get your mind thinking a specific way. Okay? Eventually we'll use it for stuff, but right now we're not. All right. Next one is inverse. You can ignore the other thing that's up there because that ties into the other example. Okay. You guys read that? No, I gotta pull it down. Right. So inverse, this, when we go through the words, if I would have just gone through them in the beginning, this is normally what gets confused for this one. Just because people think invert means you flip it, but in the case what we're doing, inverse means you do the opposite of what the original is. So negate here means change it from like a positive statement to a negative statement or vice versa. Such as, if my original said, my original hypothesis was it's hot, and I want to negate that, that would change to it's not hot. That's a whole. Okay? Now you don't want to say cold. That's that means you're completely like altering the statement. Okay? All you want to do is negate what's up there. So you don't want to change specific words. So if I did the inverse of it, it would read if it is not hot. Then, and again, I'm taking this original and I'm negating it. I'm not switching words. I'm not saying like it's dark out or whatever. I'm just saying the sun's not out. Okay. Again, I'm not using this for anything. It's just going to be, hey, this is rewriting, and there isn't much else to it right now. Okay. All right. The last one, the contrapositive, is just a combination of those two. So it means I'm going to take my original, I'm going to reverse the positions of the hypothesis conclusion, and then I'll negate it. So it's like the negation of the converse, which we already have up there. I've already got the converse there. So if I took this one and negated it, then we'd be fine. Okay, so if I wrote the contrapositive of what the original was, contrapositive would say if it is, if the sun is not out, then it's not hot. Now, out of all those, the ones you're using the most is the original conditional statement and a converse. Those are going to be the ones we use the most. All right, the contrapositive doesn't come up a lot. Inverse sometimes. But you do need to be familiar with those because I do know they come up on like state tests and stuff. Okay. But for the sake of what we'll be working with for the rest of the course. You really need to be able to rewrite a converse and a conditional statement. Okay? All right, so make sure you haven't confused anything up there. Now, with an original and a converse, the reason these are going to be things that you use the most is we run into properties here a lot. The properties are written in if-then form. If I can take a property that's written in if-then form, switch it around so I have a converse that also makes sense, then you can create something that is called a biconditional, right? A biconditional statement is written in if and only if form, okay? Meaning that you're not going to start it with an if, you're not going to have a then in there. What you're going to do is you're going to take a hypothesis and a conclusion, and you're just going to link them together with the term if and only if. This is a common way to write a definition. Definitions are actually all in the form of a biconditional. Whether or not they're written that way or not is different, but the way they got proven in here is you tested original conditional, you tested a converse, they were both okay, therefore you made a biconditional. All right. Just to show you what it would look like, if I took this here and I said like, I know that the original statement and I know this statement here, the converse, were always true. Like, meaning, if it's hot out, the sun's out, that's true. The sun's out, it's hot out, that's true. If I knew those were both true all the time, I could then go and create a biconditional statement for it. The way it would look is, it would look like me taking just this portion of it. Okay, this is the hypothesis and conclusion of the original. And writing, so it would say, it is hot if someone's out. So this would be a biconditional formed with that original conditional statement. Okay? Now, it wouldn't make sense for me to do it here. Like, this wouldn't really be a good statement to write in terms of us trying to prove things, because that's really not a statement that's always true, is it? Does the sun have to be out for it to be hot? No, I hope not. And vice versa, it doesn't have to be hot for the sun to be out. So since I know that that's not really a fact, this honestly would not be a true biconditional, would not be something that you probably would write. That I have it written simply so here you can see what it looks like, and that's really it. Okay. Let's see what else I got up there. And then also what you should write out is that portion of it. Here you have that. Because if it says, hey, here's a biconditional, is it a true biconditional? The only way a biconditional is true is if you take it, split it apart into two statements. The two statements would be a conditional statement and the converse of that, and then you test to see both of them are true. It's a little involved. It sounds more involved, I guess, than it really is, because you can do most of that kind of in your head. Like the biconditional that's up there says two angles are congruent if and only if they have the same measure. So if I gave you that problem and I said, look, here's a biconditional, and I asked you just, is that a true biconditional? What's your inclination? Do you think that's a true biconditional first before I do it?
Yeah.
Yeah? Yeah?
Wait, what?
Wait, what? You just agreed
Wait.
to what? I said, is this the statement right here? Do you think that's a true statement. True biconditional. Yes, no. Doesn't matter if you're right or wrong. I'm just asking your opinion, honestly. Yeah? I'm pretty sure if you said yes here, I'm leaning towards you being on the correct side. So if I said, look, test this statement and see, is this a true biconditional? Like if this was on a test, this is all the work I would expect to see. I would take this statement, I would write it as a conditional. Meaning I would take it and put it back into if-then form. So I would take what's up there and write it as if two angles are congruent, then they have the same measure. Okay? I would say, all right, I wrote a conditional with it now. Like I would expect this would be the work portion of this. So if you had this question on the test where I gave you a biconditional and I said, look, is this a true biconditional? I would expect this to be written out. Then kind of below it or something, I would expect to either see a true or false with this, such as, is that a true statement? Two angles are congruent. Do they have the same measure? Yes or no? Yes. Okay, so I would say, all right, that's true. As soon as I see this is true, then the next step would be you write out the converse of it. So again, all of this stuff would have to happen. This would be all the work I would expect to see. And this, the converse would be if two angles have the same measure and they are congruent. I would do the same thing. I would say, all right, now I wrote the converse. Is this a true or false statement? Is that true or false? If they have the same measure, would I also be able to call them congruent? Is it yes or no? You say no just because the other one was true? Is this true or false? Think about it. Just tell me. You think it's false? Oh, come on, speak up.
It's false.
I'm not going to throw something at you. What? You think it's true? What was the definition of congruent? They're both equal, right? So that means that this is still true. Based on what you just told me. The definition you just told me.
But I thought it was
I didn't say
inside the
just
shape.
equal wood.
It is, but they still have the same
Oh,
measure.
measure.
They're both angles. This is saying that they're both the same shape.
Okay.
They're both angles.
Yeah.
The shape thing only matters if we're dealing with like polygons and stuff. Okay. All right. So now once you get through here, again, the question would have been, here it is, like on the test. You're doing the test. You run into this statement, and I say, is this a true biconditional? And I would say, like, write out all your steps and so on. I would expect to see this written, which is the conditional of it. Just again, taking here's a hypothesis and that part of there's conclusion. And saying it's true. Once you get that true, you write the converse. Once we decide that's true, then we say, look, since both of these things are true, that means that is a true biconditional. That would be the whole problem. So if the question was, is that a true biconditional, it would be yes. But again, I would, to make it more of a problem, I'd say you need to show all of that work that's up there. This whole like symbolic logic is essentially shortening down what you have to write. It's pretty much what it comes down to, especially for you guys. All that's going to happen is now instead of me having like huge sentences, they're going to be condensed to things that look like that. Like that would be entailing an entire conditional statement, right as it is, which is much quicker to write than if you did like an entire if-then thing. Okay? There are 4 main symbols that you guys need to know to write all these statements out. And they're going to be things like this. Okay? There's going to be another one that's this way and another one that's that way. But before we actually do it, so I can write examples out, I'm going to have to tell you what the letters stand for. Like, you're always going to have symbols and letters together with this stuff. And again, this is like kind of this is an extremely brief introduction to this. Okay?
Bye.
Right? Where I'm just picking these two letters. They don't have to be P and Q. It's just what, I don't know, symbolically that's what they use a lot of. P, Q, R, and S, and T, and so on. They stick to that part of the alphabet. I don't know why. And instead of me writing like if this is going to happen, so on, so on, so on, these two statements, I'm going to treat them kind of like a hypothesis and conclusion, just so you can link it to something else. Such as P could be, I don't know, give me something like a hypothesis or a conclusion. I don't want an if with it, just a statement at the end. Like the last one we had was, it's hot, that kind of, something like that. Give me an example.
It's cold.
All right. It. Cool. Give me something else. They don't have to link together. It can be whatever you want. What? I don't know. What'd you say? I heard dark. That's all I heard. When it's dark. It's dark. Give me one more. So we'll make big ones out of this.
It is windy.
It's windy. Really sticking with the weather, aren't we? So never float your boat, man. Okay, so now before we start getting right in, okay, I've got what I've defined. All right, so what this section would be telling me in terms of this, it's basically saying from this point on, anywhere I see the letter P, that's what it's representing. Anywhere I see Q, that's what that's representing, and R is the windy word. Okay? So that when I write those statements like I had the P and Q, that means that if I wanted to take what I had and translate it into words, I saw a P there, I can write whatever the heck I got over there. All right. The other symbols are going to be, there's that one, there's that one, there's that one, and then there's that one. Okay? I'll tell you in terms of words what they translate to, because really that's what you guys are going to be practicing. Again, this is just like logical thought process practice, and that's it. Okay, you guys don't necessarily, we don't spend enough time in logic to actually use these. Okay, that would be an entire course. Okay? All right. Anywhere you see this symbol, it's like an upside down V. In terms of words, this translates to and. Okay. The one that's the actual V, that translates to or. Right. This one here, it doesn't technically translate to one word. It's more represents a statement. If you see an arrow, in terms of logic, this is called an implication. Like something implies something else, which is a hypothesis conclusion kind of thing, which is translated almost into this is your if-then statement. Right? Keeping in mind anything that's on the left-hand side of that arrow comes right after the word if, and anything that's on the right-hand side comes after the then. Okay, so it's almost like if you saw an arrow, this would be your hypothesis portion, this would be the conclusion portion. So whatever's on the left-hand side is the hypothesis, whatever's on the right-hand side is the conclusion. All right, and this symbol, again, this doesn't necessarily translate to one word. This just stands for like the negation. Okay? So if you have a positive positive statement to start with, you change it to negative or vice versa. Okay? All right, so something I might give you here, I would go, all right, I've got my letters here. Now you know what a couple of symbols mean. There's more symbols that exist than that. It's just, this is the realm of what you guys deal with. And I would say, okay, now that I've got all this defined, I'm going to write a statement in symbols, and I'll say, translate this to words. Okay, translate it so it reads in like proper sentence form, like in English class. Okay, so it would be like, let's say, translate, let's say symbolic statement. All right, and I'll do, we'll start with a short one. We'll do that. Okay. So the way you go through this is like you work at it left to right. Okay. Whenever you see a symbol or a letter, you pull out what that symbol or letter means, write it down, and you just link them together like you would from left to right. Meaning, I see this one. If I work at this from left to right, Q's the first letter. So I go, all right, Q's the first thing I see. I'm going to go to the letter Q. That's what I'm going to write. So this thing would translate to, it is dark. That's the portion that's Q. Then I got this symbol. I go, all right, I have a list of these, those four. What word does this one translate to? So I put an and there. Here's that one. And then the last thing I see is an R. So that'd be, so it is dark and it's windy. That'd be the whole statement. I'm not necessarily doing anything with it besides writing it, and that's pretty much it. Okay? It's just an active translations right now. Okay? I'll do one with the if-then here. We'll do more than one statement. Whatever, use Q and R, so we'll do that. Which one do you want to use, Q or R?
Q.
Q. All right, so we're going to do that together. Okay. So, all right, so here's how I would deal with this if I was translating it. I would see the arrow first. I go, all right, arrow means if then. That means that when I start translating this, I'm going to start with the word if, because I know that has to be there because I've got my implication arrow there. Right. This part here is on the left-hand side, the P. And that's all that's on the left. So this is all that comes after the if part. So this is like the hypothesis portion. Right? And the hypothesis and the conditional is what comes right after it. What is the P one? It is cold. So if it is cold, all right, now so I'm done with everything that's on the left-hand side, so now I'm going to throw then there. Okay, so if it's cold then, all right, and then everything that's on this side, wherever the arrow is pointing, be the conclusion. Okay, so it's saying I'm using the statement that's Q, but I'm going to negate it because I got the little squiggly mark there. So Q was dark, so if I negate it is dark, it would just be, it's not dark. Let's negate it. Negate. Change it from positive to negative, or from negative to positive. Alright, I'm going to do one more. And this one we'll do as a bigger one. We'll use all three together. So I'll do like, we'll do Q. So I got three symbols up there. I got three of the different statements. Fine. Okay. Again, look, the first thing I would do if I had this statement there, and you also might see this with like little parentheses around it. I just didn't put them up there. You can add them if you want. But the first thing I would do if I saw this is I would go, oh, there's an arrow. That's if then. All right, that means I need an if there, and then eventually I'll have a then. Okay, I'm not going to put the other word until I stop with the hypothesis. Is all of this stuff right here on the left-hand side of that arrow? Yes or no? This whole thing, is it on the left-hand side? It's not a trick question, guys. Okay. Here's the arrow, that's the left arrow. So here's your hypothesis. So that means this whole chunk, everything that's within this, has to go right here. Okay, so now I'm to translating what the Q and then the VP thing. All right, so from left to right, I write statement Q, which was it's dark. So it is, if it is dark, that was or cold. Or I can just put cold. It's fine. You can cancel letters out or words. I mean, as long as it reads okay and you're not really changing the context of the statements, that's fine. Okay. So there's my if. I took care of everything that was on the left-hand side. I hit my arrow. There's my arrow. So that was that part. That's the P. That's the Q. All right. Then what was that? What did you say? What did you say? Again, I could go through and do like true or falses with this, but when you start making like long statements, more than likely, especially in here, they're going to be like false statements. Okay. Do I need to do another one?
No.
Is that all right? All right. One last thing with this, it kind of falls into this one. All right. All right. Last thing would be if you got Venn diagram stuff. The only thing you guys are doing with this is you're taking something where you're going to have a Venn diagram. You're going to write a conditional with it. Okay. The only way you can write a conditional, like an if-then statement, is if you have one portion of your Venn diagram completely enclosed within the other one. If you have like the two that you guys would be used to seeing where they're just interlocked over one section, then you could throw in like the V's and the upside down V's and that kind of stuff. But what you guys are going to be doing with these diagrams, the only way this is going to work is if you got one portion of it like completely enclosed within another one. You just kind of have to remember what part is going to be the hypothesis and what part is going to be the conclusion. Okay? All right. The way this will always work is the smaller one, the one that's inside it, is going to be the hypothesis. The bigger one's going to be the conclusion.